Okay. Let's see. All right. Final bell ring. We have one more. So we're missing a bunch of people. Okay, so for you guys out on Zoom, the notes are, I'm going to go over some of the problems on the notes for 5.5, which was your assignment on Delta Math yesterday, and it's due tonight. There we go. Okay, so if you want to find your notes, 5.5 on Delta Math in the unit 5, let everybody get in here. The notes 5.5 on CTLS covers the topics that are on the Delta Math that you may have started last night and probably have questions on. So let's see. Give me a minute here. All right. Okay, so let me. Okay, so a couple of things. We're gonna do some of the problem on the notes for 5.5. Like I said yesterday, though, that part of this part of the circles, all the circles units that we're going to do, what we're doing on 5.5 is not going to be emphasized much on the test that you have on Thursday, which is why yesterday I wanted to go through all the missed problems on the Unit 4 test and spend time doing that. That's going to be much more emphasized on the unit test that we have this Thursday compared to what's on your homework on the Delta Math 5.5. So what we'll do today, we're going to do some of the problems on the notes for 5.5. We're going to, I'm going to try to give you guys time to work on either finishing up the Delta Math on 5.5, which if you started last night, you probably do have some questions on. Also remember that there's a classwork 5.6, and that is on Go Formative. It is due for a grade. We talked about that yesterday. The PDF of the problems is on CTLS in the Unit 5 folder, and this is a review, so it covers Units 3, 4, and 5. It's kind of long, which is why I went ahead and opened it yesterday. And so you definitely want to give yourself some time to work on it. It's due tomorrow at 8 a.m. and it does count for a grade. So you want to make sure and do that. And then you also have tomorrow's, you have your Delta Math 5.6. So if you're kind of ahead of the curve and want to get started on that, that would be smart to go ahead and do that. That's a review. And so that has a bunch of problems from Unit 3, 4, and 5. Our test is Thursday. So, and as we said yesterday, it will be all multiple choice. It covers Unit 3, 4, and 5. So it's cumulative. Since it is multiple choice, I think you will, it'll help keep us from making silly mistakes like leaving pi out of the answer or giving a decimal answer when it should be exact, that kind of thing. But don't be fooled that just because it's multiple choice, it'll be super easy, because there's a lot of stuff in these circle units, right? So since it covers Unit 3, 4, and 5, there's really a lot of material. So I hope that you'll go back and review all your notes. And then also remember yesterday I gave you the review sheets, circles part 1 and circles part 2. And they look kind of like notes because they do have notes on the left side, but they have a little problem that goes with each topic. So that's a really good, just kind of basic review of each thing we've done. Not comprehensive, but definitely you want to review that. The other thing, I just opened your unit, bless you, I just opened your unit 5 quiz up on Go Formative. So now you can log back in and look at that and see how you did and what you missed. And look that over. If you'll take a look at that before we meet again tomorrow, I'll go over the quiz in detail and answer any questions you guys have. So my goal for today is to do some problems for notes 5.5, and then I want to give you time to work on what you need to work on. And then tomorrow in class, we're going to have a big review day. So it'll be kind of like help session review. Yeah, question.
Is there an answer to that review thing that you were just talking about with the multiple sides?
This? Yeah. Yes, there is. So the question is, do I have an answer key for the circles part 1 and part 2? Yes, I do. And I can post that on in the unit 5 folder on CTLS. They're, mine are separate, but yours should have been stapled together if you picked one up. So if you look on CTLS, though, they're 2 different PDFs. Okay. Okay. Okay, so let's go ahead and look at the notes for 5.5 and do some of those problems. I'm going to kind of jump around a little bit because I'm not going to, some of the problems on these notes are much harder than you're going to have to know for Thursday. So I just don't want you to stress out too much and think, oh my gosh, there's all this algebra, and there is a lot of algebra on all this, but the Delta math is definitely harder than what you'll have to do for the quiz. And I think the notes that we have here is harder than what's on the Delta math. Does that make sense? So the big idea is when you're solving systems of equations, it's very similar to when you were solving systems of equations when you just have 2 lines, right? Remember when you're solving, when you're given 2 equations of lines, you may, if they intersect, like if they cross as an X, you get one solution. They cross at one point. You could also have where they might be parallel and they never intersect, so you'd have no solution. And then you might have the situation where the line was actually the same line, and it would be like infinite many solutions, like all real numbers. Remember those? Kind of the same idea with circles. So with circles, we have 3 different possibilities. So we could have this first possibility where the line never intersects the circle. It never crosses. And so we would end up with no solutions. Most of the time, on the problems that you'll see, we will have a solution, and the line will either touch the circle at exactly one point, so where it's tangent, so you would end up with one solution, one point where it works for both the line and the circle, they share the same point, or you get 2 points when you have a secant, and it crosses, a line crosses through a circle and intersects that circle in 2 different places. So when you're asked to solve the system of equation, when we're working with circles, what you're looking for are the coordinate points, so your X and Y value that is the same point in both the line and the circle. Okay? So this first problem, I'm going to skip it on the notes because X squared plus Y squared, that's easy to find the center, right? That's 0, 0. But the radius is kind of nasty to graph because it's the square root of 20. And so I'm going to skip that one, and we're going to do number 2 here. So I copied number 2 over here, but this matches your number 2 on your notes page. I just tried to make it a little bit bigger. And so what I'm going to do though is I'm going to add a little bit to the problem number 2. So we're going to work with number 2, and then I'm going to add a few more little, like part A, part B, part C kind of thing. So we'll do this one first. This will be our part A. Okay. Y'all with me on 5.5? You found it? It should be in your notes packet that you've had for you guys who've been in class. It's in your notes packet that's printed out. Okay, so when we graph a circle, what do we want to find first? The center and the radius. So the center of this one would be, and the radius should be 5, right? If I go ahead and graph that really quickly, -2, 2, and then the radius is 5. Okay. And then just to help me draw it a little bit, they give me this hint here that 1, 6 is on the circle. So 1, 6 would be 1, 6. Right? Since I know that the point 1, 6 is on the circle, remember if I count from the center here, over 1, 2, 3, so that's over 3 and up, over 3 up 4. Remember from the center, I can then go left 3 up 4, left 3 down 4, right 3 down 4, and it just helps me graph the circle more accurately. I have a point there, there, and there. So it gives me a hint up here, right? That 1, 6 is on the circle. And so what I'm doing is from the center, so the center is right here, right? That's the center. From the center, if I know that the point 1, 6 is on the circle, from the center, you can count to the right 3 and up 4 to get to that point 1, 6. And so what it's saying is that if I know if I'm going right 3 up 4 in this direction, that means from the center, I would also go left 3 up 4, right? I go left 3 down 4 and right 3 down 4. All 4 of those blue points would have to be on the circle. The other thing I know is I can flip the order of that. Instead of going over 3 up 4, I can go, let's see, over 1, 2, 3, 4, and up 3. That will also be on the circle. Over 4, up 3. Over 4, up 3. Over 4, down 3. And over 4, down 3. So I'm just counting. It's kind of like slope. You're just counting over and up the distance to get to the point. If you remember, we made those little right triangles last week and we kind of used it to graph our circle. The only reason I'm doing that is to try to get an accurate graph of my circle. I'm going to go erase my little arrows here, leave my dots, but I'll clean it up here a little bit. Right, and then I'll make my circle. Okay, so just trying to clean it up so we don't have colored lines everywhere. All right, so now when I graph my circle, it should be a little bit more accurate. So I did my radius was 5, and then I can go through all my dots. And that's how I can graph 12 accurate points on my circle pretty fast and easy. on your test, you won't have to graph a circle, but you will be given graphs of circles, like on Delta Math on the homework tonight. And so if the circle nicely fits on a graph, and if the line that you're talking about fits nicely on a graph, count, use the graph, like just use the graph to solve. It's so much easier than trying to do everything with algebra. Okay, so what we're gonna do, we're gonna find the point where this line that we're given here in our equation intersects that circle, if at all. Okay, so a couple of steps with this. The first step is write the equation of the line in slope-intercept form. So in other words, I'm going to solve for y. I just need to make it easy for me to graph. Okay. So if I rewrite this in slope-intercept form, if I add the y to the right side, and subtract the 7, you see how I would get y is equal to negative 2x minus 7? Do we all get that? It would be bad if we couldn't graph the line, and then that would mess our whole answer up, right? So once I do that, I'm going to graph it. Okay, so I'm going to graph the line. So when I graph the line, I think the easiest way to do that is to start with the y-intercept, which is at 0, negative 7, right? Because I have negative 7 is my b, and the y equals mx plus b. And then the slope is negative 2. So if I start at 0, negative 7, I'll make my line circle. So 0, negative 7, that's my y-intercept. And then I'm going to count a slope of negative 2. So remember, if you look at your graph, one way to remember the negative slope is look at your graph, lift your left arm and say, okay, I know it needs to go that way. That's negative. Left arm's negative. So since it's negative 2, I'm going to count up to and over 1, up to and over 1. Ah, that intersects my circle right there. Up to, over 1, up to, over 1, up to, over 1, up to, over 1. So I found my 2 points that intersect my circle. And the points on the line, just to make them a little clearer, because I was counting my slope. So the points on the line are these black ones right here, right? So. All right, so that's the equation of my line that I graphed. All right, and so the 2 points that the line shares in common with the circle, I can just look at my graph and say, okay, what's this one? This is negative 2, 1, 2, 3, negative 2, negative 3. What do we get over here? 1, 2, 3, 4, 5, 6. Negative 6, 5. Right? So on my notes here, when it says number of intersections, I have 2 intersections with the secant line. And what are my solutions? I have 2 of them. Negative 6, 5, and negative 2, negative 3. All right. So you always want to write your solution as a coordinate point. Don't just say, oh, it's where x equals negative 6. You can't do that. You have to say it's where, like on this point, x is negative 6, y is 5. So you have to write it as a coordinate point. And in this case, I have 2 solutions. So that's definitely the easiest way for that problem would be to graph it, just like we did. Right? Does that make sense? Is that not too bad? Okay, so what I'm gonna do is I'm gonna add to this problem. So we're gonna add like a part B, right? Part B and C. So right there, what we just did, that's as hard as it's gonna get on the test on Thursday. Okay, so if you can do that, if you can find the points of intersection, the solutions for a line that has a slanted slope with a circle, you're gonna be fine doing that, okay? Kind of a more simple example would be this part B I'm gonna add. So find okay, so I'm adding part B to the problem. So another type of problem might say, find the solution or solutions, if any, for the same circle above and the line with the equation x equals 3. Well, so those show up a little bit more often. So let's look at our graph. So what does x equal -3 look like? A vertical line at x equals 3, right? So kind of our 1, 2, 3, and there's my x equals 3. Whoop. So x equals would be a vertical line, held constant, x is held constant where it equals 3. So that's easier, right? So I just look where they intersect and what do you know? Right there. So where x equals 3, then I need to just look at my graph and say, what's the y coordinate? So it would be 3, 2, right? All right. So what do you think when it's an x equals problem? What do you think about the solution? It has to have what for its x value in the coordinate point? Well, it has to be the same. If I'm holding x constant, right? X equals 3. The coordinate point has to be 3 comma something, right? So let's do another example. Okay, same problem. Let's see. Okay, sorry, I had to check my graph here. The line y equals 7. Same circle, line y equals 7. Let's get the whole graph. So first I want to graph the line y equals 7. What's that going to look like? Flat line, right? All right, so 7. 1, 2, 1, 2, 3, 4, 5, 6, 7. Here. So this point then is going to be something comma 7, right? Because I have y equals 7. So now I just have to look at the graph and say, what's the x value? It's like -2, right? Pretty easy? Okay, so this is a lot more realistic about what you're expected to be able to do as far as graphing and solving systems of equations. Nothing too crazy complicated. If you look at the second page of the notes, though, let's do one of them algebraically. Let's see. Let's do this one. If you look at the second page of notes, on number 3 here. when it says solve the system algebraically, that just means we're going to plug something in for X or plug something in for Y, use substitution, and find the values of Y that satisfy the equation. So on a problem like number 3, that doesn't graph very nicely, does it? Like the center would be easy, right? The center would be 0, 0. But the radius is the square root of 10, which is kind of awkward to graph. So we can kind of estimate it, but if you're actually trying to solve for points that work on both the line and the graph, it's a little bit harder. So this is an example where you would solve for it algebraically instead of graphing. So if we're given this line x equals 3, what do I do with that? How do I solve? Can I substitute that in somewhere? Like there, right? So I'm just going to use substitution. Right? And I'm going to put this x into that equation. So I'm going to end up with 3 squared plus y squared equals 10. And 3 squared is 9. So 10 minus 9 is 1. So when I take the square root, this is where I have to be a little bit careful. So let's write it over here. When I take the square root, remember you have to do plus or minus 1, right? So I'm going to end up with plus or minus 1. So y could be 1 or negative 1. So what would my points be? There you go. Okay, and then I can check these in my equation of the circle just to make sure they both work. But if I have negative 1 plus, sorry, I just put that in for x. Check it. With 3 squared, sorry, there we go, 3 squared plus negative 1 squared. Does that equal 10? Yes, it does, because any negative number is going to be a positive number once I square it, right? So I'm going to get 9 plus 1 equals 10. That works. And then 3 squared plus 1 squared equals 10. That works too. So both of those would be solutions to that problem. All right. On Delta Math, you do have 3 problems at the very end that are kind of complicated. And they require that you use substitution, just like we did above. But they're giving you an equation of a line instead of just saying x equals 3 or y equals 2 or something easy to use. They're giving us something like this, where you have the equation of a line is y equals x minus 2. So what you need to do on that one is still use substitution, but I have to substitute x minus 2 in for y instead of a number. So it gets a little messy, but when we do that, we'll have x squared plus, instead of y, I'm going to put x minus 2 squared equals 10. So what do I do when I have to square x minus 2 quantity squared? What do you have to do with that? Yeah, like FOIL it, right? Everybody's kind of going, oh. Okay, so I have to write it out. And then I'm going to distribute. So I'm going to get x squared minus 2 plus 4. And then don't forget about this guy. Equals 10. Run out of space. And so I'm going to consolidate these guys. So I get 2x squared minus 4x. I'm going to subtract the 10 from the 4. myself a step here, right? And set it all equal to 0. How am I going to solve for x? To factor, right? What should I do first before I try to factor that? Or yeah, or divide by, like factor out your undistribute. I know you're thinking the right thing, exactly. So I'm going to divide everything by 2. And so I get x squared minus 2x minus 3 equals 0. Can we factor that? Yes, we can. We get x and x. A negative there, so my signs have to be plus and minus. So I end up with plus 1, but careful, not 2, 3, right? Okay, so 3 is the bigger number, and so it goes with the sign that's there. So negative 3, positive 1. When I solve for x here, remember, I'm actually setting each one of those equal to 0 and solving for x. So I get x equals negative 1 and x equals 3. Am I finished? Is that my answer? No, I have to write it as a coordinate pair. So I'm going to have negative 1 comma something and 3 comma something. So how do I figure out the y value that goes in there and in there? Yeah, perfect. So I'm going to go back to this guy, my line, and I said, okay, I know y equals x minus 2. So the first one, we said that's negative 1. So that becomes negative 3. That goes in there. All right, and then the second one would be, is it negative? Yeah, no, is that, okay. 3, sorry, minus 2. I thought for a second I covered up a negative, but that was the last problem, wasn't it? So I have negative 1, negative 3, and 3 comma 1. And then I can plug both of these into my circle equation to check them and see if it works. So if I plug in negative 1 here, I'd have 1 plus, and then negative 3 squared would be 9. So 1 plus 9 equals 10. That works. And then the second point, I have 9 plus 1 equals 10. So they both work. Yay. So we checked it. We wrote them as coordinate pairs. That's the biggest thing people forget to do, I think. Yeah, Kayla. Yeah, it did. It did. And the reason it did mainly was because the question was, did it just so happen that they were kind of reciprocal numbers in the different coordinates? The reason it worked that way is because the center is at the origin of the circle. Does that make, like, if you can picture it graph? It will not always be super nice like that, but okay, so it's not too bad. Like the ones like number 5, those are pretty easy, right? When it says x equals something, you just plug that in for your x and solve for y. So I think that some of the problems on Delta Math are a little bit more challenging than maybe what they should be. I don't know. But some of them are multiple choice too. So remember, if they give you multiple choice answers, you can plug in the points and make sure that they work in both the circle and the line. And I can show you what I'm talking about if you have questions about that. So what else? Questions? Did that make more sense? Are we good with that? Do we need to do more? Okay. Let me just show you, see if I can, I'll show you what I mean on Delta Math. How many of you guys have started that on Delta Math? So we did okay? Okay, and then you know that there are videos on Delta Math too. If you need more help, you can watch the video. But let me just. Let's see. So this is your homework on Delta Math. You have 5-5. If we go back and. Get transparent. Okay, so for example, on number 1, it's kind of nice on these problems because they're actually giving us a graph that's already graphed nicely and we can just count, right? So on this problem, on number 1, we just have to make sure that we graph that line correctly. So it says y equals negative x plus 6. So what's the slope of that line? Say it again. Somebody said it out there in Zoom world. What do you do if it just says negative x? What's the slope of that? -1. Okay, I've had a ton of questions on that. So if there's not a number in front of the x, it's 1, right? So if it's negative x, it's -1. So the slope is -1, and the y-intercept is at 0, 6, 0, 6, -1 slope, right? And then down here, I have all my multiple choice options. And what do you know? Here's 0, 6, and 5, 1. So that would be my answer. But when you're given these multiple choice options, you can use that to your advantage, right? Little test strategy here. So let's say I got kind of confused and maybe I wasn't sure what I was doing, or I just thought it might be faster. I can start with the points and graph those and see if they work in both the circle and the line. The key is they have to work in both the circle and the line. So 0, 0, well, that's on the circle right there. And 5, 5, whoop, that's on the circle. But it's not going to be on my line, right? And I can tell that it's not going to be on my line as long as I realize that my line that I'm working with has a negative slope. These points, if I connected those and made a line, would have a positive slope. So even if I don't know exactly what the line looks like, you could rule that one out because it won't work. And then some of these won't even be in the right quadrant, right? -1, 5, okay, that works. But 0, 6, it would have to go this way. So that would also have to have a positive slope. And 2, 3, that's not even on the circle. And 3, 2, that's not even on the circle. So, you know, when you have your test on Thursday, it's going to be all multiple choice. So you can use a lot of the, like, you don't have to graph the circle necessarily perfectly, but if you can sketch it out, sometimes the points that you're given won't even be like in the same quadrant as the circle. So just rule that out. Okay. Okay, so I'm going to give you the rest of the time. You have about 15 minutes or so. You can work on the classwork. I'll go back to that slide so in case anybody, we had a couple people late. So the test is on Thursday, right? It covers unit 3, 4, and 5. You can finish your Delta Math 5-5. The classwork 5-6 is due on Go Formative. It's 40 problems. It's kind of long, which is why I assigned it yesterday, and you have till tomorrow at 8. And then your Unit 5 quiz is open. I have one more exciting piece of news about the test. You ready? So you know it covers Unit 3, 4, and 5. And I know some of you guys are not happy about how you did on the Unit 4 test. Some maybe did better on 4 than 3, but either one of those. What we are going to do is if you do better on the Unit 5 test than you did on either Unit 3 or Unit 4, we'll take the lowest grade from Unit 3 or Unit 4 and average that with whatever you get on the Unit 5 test and put that grade in for whatever your low test grade was on Unit 3 or Unit 4. So it'll only be on one of those two tests, and we'll average your grade together. So let's say you normally do really well on a test and you just screwed up and you forgot pi on half your answers on the Unit 4 test, and it's just kind of crazy. Well, so say you got a 60 on the Unit 4 test and you do really well on the Unit 5 test, so you get 100 on the Unit 5 test. Because it's multiple choice, that's doable. You can do this. You're going to end up with an 80 instead of a 60 for that Unit 4 test grade. So it really could help you out quite a bit. So I would definitely encourage you to really study and prepare for the Unit 5 test. And, you know, like I said, we put a lot of review stuff out there on CTLS. I will put the answers, I'll do that right now. I'll put the answers to the extra practice circles part 1 and 2. And then remember, you can go back and look at all your quizzes on Go Formative, all the tests that we had on Go Formative, see what you missed before, see what kind of problems were challenging. You can look at the reviews that we've done on Go Formative. So there's lots of stuff out there. You can also watch all the YouTube videos that are out there, the playlist for 3, 4, and 5. And then of course there's videos on Delta Math too. So, okay, well, I'm here if you guys have questions. Otherwise, I'll let you use some of the time to work. Yeah, question. Okay, I will change it to 8 a.m. Thank you.
Oh, sorry. I didn't know we were allowed to go.
Well, everyone jumped off as soon as I said you can use this time to work unless you have questions. So I guess you're free to go.
Okay,
Or you
thank you.
can stay if you have questions. Either one is fine. That's where. Okay. Oh, I left it open till tomorrow at 11:55. Is that confusing if I do that? It's still due at 8 a.m., but I know people aren't going to have it all finished, so I was going to count it as a, I don't know. Maybe I should change it to 8 if I said that. I don't know how it shows up for you guys. If that makes it confusing, I don't want to make it confusing. Yeah, it would. Okay. Okay. Thank you. I will fix that. Sometimes it's hard to know how it shows up, you know, like on from the students. Got it. Okay. Yeah, that would be bad. All right. So I will fix it right this second. Okay, I fixed it.